Today's lesson is the quadratic parent function, which is y equals x squared. You may recall from before that we've looked at the linear parent function, which was y equals x, and we've also looked at the absolute value parent function, which was y equals the absolute value of x. Both of these equations are basic equations that start at the origin, and so will this one. Its center will be at 0, 0. You may recall the catchy phrase that this is the mother function that doesn't give a shift because it's not shifted right or left, it's not up or down, and it doesn't have any shrink or stretch. So we're going to look at some of these equations, but first, before we go any further, I want to show you what y equals x squared looks like. It is a parabola. You may remember the word parabola from Algebra 1, and it does go through 0, 0. That's where the vertex is, and it goes up on this side and it goes up on this side, and although it's not really clear with my picture, it does have symmetry. So if you were to fold it across the y-axis, it would have symmetry. So this is what the basic quadratic function looks like. This is y equals x squared. If we want to do some shifts, we can see what happens when we add 3 to the end of x squared. So if you recall from when we did absolute value, the plus 3 at the end means we shift this up 3 units. So 1, 2, 3 is my new beginning point, and I'm going to go up and to the right and up and to the left. If you're curious, this very first point from the vertex, the very first point you come across is going to be 1 up and 1 over. So it's almost like it has a slope of 1, except for then it curves, and so it's not like a line. So plus 3 means this shifts up 3 units. And if it was negative, then it would shift down. Alright, also just like before, we have x world, and anything in x world moves the opposite direction. So x minus 3 seems like it should move to the left, but since we're doing opposite, it's going to move to the right. So we're going to shift right 3 units. That'll be my new vertex. I can go up 1 into the right one, and I can go up 1 into the left one if you want a little guide. And then I'm just going to curve this up to make a U. So x minus 3 parentheses squared. The square tells us that it's a parabola, and x minus 3 tells us that it's been shifted to the right 3 places. The next type of shift or transformation is if there's a number in front. Now remember, this sort of works a little bit like a slope. So the normal slope we had before was a slope of up 1 over 1. So this time, when we do this equation, we are going to start at the origin. So we're going to put our point at the origin. And now instead of going up 1 over 1, my first point to the right will be up 2 over 1. And my first point to the left will be up 2 back 1. And then when I connect it, I'm still going to make a U, which is sort of hard to do on this, but y equals 2x squared is just skinnier. So this is a stretch. Anytime your number is a number greater than 1, it will be a stretch. Okay, the last type that we're going to look at in this video is what do we do if there's a negative. Remember, the negative in front tells us that it's going to be a reflection. So instead of going upwards and making an upward U, it's going to be upside down, and some people call that a hill. So it does still start at the origin because it's not shifted right and it's not shifted left. And because it goes opposite of what the normal x squared function is, then it goes this way, and it goes this way. And notice that it hits these points here where it's one box over. So one over right and down, and one over left and down, to give you these two kind of guiding points that help you to draw the U. So that's your 4 different types of things that can happen. Let me review real quickly. Anything after the x squared shifts up or down. Anything inside where the x world is shifts right or left, and it's always opposite. Any number that's in front of the x squared that looks like a slope is a stretch or a shrink. It's a stretch if the number's greater than 1. And if you have a negative where that slope should be, then it's a reflection, and instead of being a U, it's going to make a hill. So on your own, I've given you a real challenge here, because this has a reflection and a stretch and a shift to the right and a shift up. So you're going to draw all of these things on your own paper in your notes.